In this video lecture, we will talk about real numbers. Before we do that, we want to see what's the meaning for numerical access. Numerical access concept is a very important step of the progress in mathematics. We associate every number, every real number, with a point on a number line. For example, we put 0 here and 1, 2, 3, 4 here. We put -1, -2, -3 to the left. By convention, negative numbers is on the left. Positive numbers is on the right. So numbers on the right is bigger than the numbers on the left. Everyone knows 2 is greater than 1. Then it's easy to see -1 is greater than -3. Okay? And 3 is greater than -1. And 2 is greater than -3. So after numerical access is introduced, everything is easy to compare. You see, before everything is digitized, and we have a temperature thermometer. You see here. For the temperature, this is the classroom thermometer. So the temperature will not go to that high. And the temperature will not go to this low, like -40 Fahrenheit. Okay. Here, right-hand side is the Fahrenheit unit. Left-hand side is Celsius. In American, we use Fahrenheit. In Canada and other countries, we use Celsius. So actually, the Celsius, this unit is very convenient. You can see the ice point. That's from water to ice. The water is frozen at 0 degrees Celsius. That's 32 degrees in Fahrenheit. The boiling point is not marked here because this is the temperature for the classroom. The boiling point is 100 degrees for Celsius, is 212 degrees for Fahrenheit. In the vertical direction, number on the top is bigger than the number on the bottom. -10 is greater than -20. And the 20 is greater than -30. So here is easy to see. So again, numerical access is a very important progress step in mathematics. On the real number line, not only do we have integers like -3, you can go to -4 on the left. And you can go here from 3, 4, 5, 6. So going to the right. We also have a rational number. Rational number, there are two kinds. One is like 1/3. 1 divided by 3, you can see, is 333. So we write equals 0.3 plus a bar on the top of 3. So 1/3 is roughly 0.33. On the real number line, from 0 to 1, you divide into 3 parts and then choose 1 part. That's roughly here. So this place is 1/3. And between 0 and 1, we marked in the middle, that will be 1/2. Okay, so you can see which one is bigger. 1/3 is roughly here because, again, you divide 1 unit from 0 to 1 into 3 parts. And then choose 1 part, that's from 1 to the first part, that's 1/3. So 1/3 is less than 1/2. Very easy to see after we introduced numerical access. That's one kind of rational. This is repeat expansion. You can see 3 is repeated. And then there are finite decimal numbers. If you do 3 divided by 4, you know that's 3/4, which is 0.75. Where is 0.75? Like we did for 1/3, 3/4 is you divide from 0 to 1 into 4 parts, and then you choose 3 parts. So roughly it's around here, 0.75. Okay? So here, 0.75 is a finite number. Both finite decimal number and the decimal number with repeat expansion will be called rational number. So rational number is actually a fractional number, one with repeat expansion, one with finite without expansion, finite decimal. There are other numbers on the real number line, and you can see here, every calculator has a E, that's Euler constant, and has pi, which is 3.14. Here is 3, so pi is around here. E is approximately 2.128, that's around here. Around here. Radical 2 approximately is 1.414. Those numbers without repeat expansion, so it is called irrational. So not only do we have rational numbers on the real number line, we also have irrational numbers on the real number line. Rational, irrational together will fill up, no gap, on the all real number line. So what is the real number? There are 2 categories. Again, integers is a special case for the rational, because everyone knows 1 equals 1 divided by 1. 2 equals 2 divided by 1. That's a special case. So basically, integers belongs to rational. When the number is starting from 0 and then 1, 2, 3, those special integers will be called whole number. And then when the number integer starting from 1 to 3 without 0 included, those numbers will be called natural numbers. And then when the number greater than 2, there are two categories. One is prime number, another is composite number. What's the meaning for prime number? Prime number is like 2, 3, 5, 7, 11. You can see the remark right here. Composite numbers can be arranged into rectangle, but prime numbers cannot. You can see 4, there are 4 dots. 6 is a composite number. They can be arranged into a rectangle. 8, 9, 10, 11. 8, 9, 10, 12. All those numbers can be arranged in rectangle. Those numbers which cannot be arranged in a rectangle, then those numbers will be called prime number. Okay, actually, what's the meaning for the rectangle? Once you can arrange them into different rectangles. For example, 10 is 2 times 5. And here, 12 is 3 times 4. They are. Once we do more, you will see like in future, you will see like 18 is also a composite number. You can arrange 18 into 2 times 9. You can also arrange that into 3 times 6. So here, the composite number has this kind of characteristic. Okay, so here is about real numbers. Next time we'll talk about a little bit more about real numbers. So I will stop here. See you in the next video clip.